everyone, my name is Olivia Shin. I'm the project manager of UAV Forge.
I'm Wilson Luck, and I'm UAV Forge's Chief Engineer of EECS.
I'm Matthew Chu. I'm UAV Forge's Chief Engineer of MAE.
Okay, so for the background, we are a design team. We're designing and fabricating and programming an autonomous unmanned aerial vehicle, which also known as UAV. And we're going to a competition hosted by AUVSI SUAS. It's Association for Unmanned Vehicle Systems International Student Unmanned Aerial Systems Competition. We originally participated in DARPA competition, but since the DARPA competition is no longer here anymore, we now go to AUVSI competition in Maryland. Okay, for subsystem breakdown, we have an administrative team, which is led by me, and an MA team led by Matthew, and an EECS team led by Wilson. So administrative team consists of 5 different leads: logistics, documentations, safety, finances, and business marketing. Logistics is in charge of making sure that the team is going smoothly without any hardships, anything like that. And then documentations is in charge of documenting and submitting all those documents to the competition and to MAE classes. Safety is in charge of making sure everyone is safe during those flight tests and during fabrication processes. And finances and business marketing are in charge of fundraising and making sure that we have enough money to buy things that we need for the competition. And the MA team?
For the MAE team, we have 3 subteams: structures, aerodynamics, and propulsion. For the structures, they mainly consist of building the frame and then responsible for all the stresses associated with that, and then mounting the parts on the frame. For aerodynamics, they'll be responsible for the unmanned ground vehicle that will be part of competition, and also just things such as drag of the airframe and other components. And for propulsion, they're mainly responsible for the configuration and the propulsion of the quadcopter, or in our case, hexacopter, so engines, mounts, things like that.
And the EECS side has 2 subsystems, ground station and avionics. Ground station is dealing with any ground-related things such as interfacing with competition server and path planning, while avionics is working on onboard systems to the quad or hexacopter, such as power systems and flight control.
Okay, so this is our organization chart. So it has all the leaders' names and the sub-teams. So we have different sub-teams and documentation. So for documentation, there's one documentation manager for each sub-team. And for EECS, we have one documentation manager for the whole EECS side. And then for logistics, Nicole is in charge of like a leading admin team, and I am managing the whole project, and I connect those engineering teams and administrative teams together. Okay, for our goals and objectives, our goal is to win AUVSI 2020 competition in Maryland. Our objectives are design a UAV and fabricate it. We also program autonomous flight, obstacle avoidance, and air delivery, which is done by our UGV unmanned ground vehicle. And we also test UAVs so that at the competition it goes smoothly without any breakdowns. Okay, for requirements for the competition, we have mission demonstration, which is 60% of the competition. That's the actual part of the competition. We go to the competition and demonstrate that our UAV works. And then it breaks down into timeline: 10% of mission demonstration, 10% autonomous flight, 20% obstacle avoidance, object detection, classification, localization, 30%, and then airdrop, 20%, and operational excellence, 10%. So those are determined by those judges at the competition. And we have 40% of things we do here at UCI. 20% is technical design paper, which is going to be done by our documentation managers and administrative teams. Payload design is 40%, autonomous flight design is 40%, and safety and mitigations, which is gonna be done by safety manager, that's 20%. And flight readiness autonomous review is so that we demonstrate that our UAV can fly without any safety hazard. And then that's 50% developmental testing, so we show that we developed and we tested. Mission testing is 30%, and we do system overview and plan tasks. So those are UAVs that can fly and do all the operations without any safety hazard. For specification, UAV is supposed to be capable of heavier than air flight, and it's supposed to be autonomous flight and autonomous termination, and the max weight is 55 pounds. For UGVR unmanned ground vehicle, maximum speed is 10 miles per hour, and payload is 4 pounds, and then it's going to be autonomous driving as well. And then for timeline, we have registration period, which was September, and we have completed that. And then we have team formation contract document, which was due in October. We finalized design last November. And then in winter quarter, we'll begin fabrication process in January. Autonomous features will be added in February, and we start testing in spring quarter, which is March. And we send those design report to AUVSI to look into it. In April, we'll be submitting all the documentations required by the AUVSI. And in May, we submit the promotional video and safety pilot log, and we go to the competition in June.
So for current progress for the MAE team, we finished the initial design of the hexacopter design. So we'll be using 6 rotors on an airframe, and mostly structures, but also propulsion and aerodynamics are responsible for that. They've also conducted computation analysis in both ANSYS and SOLIDWORKS. So we're testing the stress of our beams that we're mounting the rotors on, and also the airframe and its drag characteristics, and also weight. And we've started fabrication on the frame. We're doing base plates and among other systems. And right now we're just waiting for purchase orders so we can complete more of the airframe.
For the EEC side, we've designed the power and cooling systems for the battery and the motors. We've also tested some of our flight control algorithms and systems in software using simulations such as AirSim and Gazebo. And we've tested and flown a test quadcopter, shown here, which we're using to test some of the onboard systems we're going to be putting onto our final quadcopters, such as cameras and other sensors.
Okay, so for summary, we are on track to finish fabrication next quarter, and we're planning to test autonomous flight at the ARC in the beginning of winter quarter, and these are the pictures of our hexacopter, its CAD model. Thank you for watching.